In this video, we're going to demonstrate how to add a foreign key reference in tables when we do a create table statement. But before we go there, let's kind of remind ourselves why we use databases and how we relate tables to each other. So taking a look at my bookstore, it has all of these tables. The ones we're going to look at right now are the customers and orders. So obviously in my customer table, I have a customer num and then information about those customers. In my order table, it's a list of all of the orders, but notice it also has a column called customer num. So the idea is I've linked these two tables through a common column, and in this case it's customer num. So for instance, I have customer 1001 has placed two orders, 1003 and 1018. Well, who is that customer? So I go to the customer table, I look up 1001, and there it is. It's Bonita Morales has placed two orders. So those two tables are linked, joined if you will, by a column called customer number. Now, in databases we have a concept called referential integrity. And what that is about is I want the database to be smart enough to not let me use a customer number in the order table that doesn't exist in the customer table. So let's say a person's entering a brand new order and they fat finger the customer number and they try to add customer number 1021 for a brand new order, and yet customer 1021 doesn't exist. We want the database to not let me do that. That's referential integrity. Don't let me put a number in the order table, customer number, that doesn't exist in the customer table. And how we establish that is through a foreign key constraint that we're going to add to the tables when we create them. In our example, to demonstrate this foreign key relationship, we're going to create a table called employee, and an employee is going to belong to a department. So we're going to create another table called department, and then that table will have an ID and name. All right, and then we're going to take that ID and also include it over here. So when I look up an employee, I can see what department they belong to. So no different than our customer and order where we had the customer number in the order table. We're going to have the department ID in the employee table. Later in the quarter, we'll learn how to read these diagrams, but basically a department can have many employees, but an employee must belong to one department at a time. So let's go write the SQL statements to create these tables and demonstrate that foreign key constraint. So running over to foreign keys, I'm going to create running over to this MySQL script. I'm going to create a database called My Company, and then I'm going to use it. All right. Now first I create my department table. Here it has a department ID that's a tiny int. I'm making it a primary key and I'm defining that at the column level, and then I put it on an auto increment, and then I have the department name. So it's going to be like accounting, engineering, finance, HR, things like that, varchar 50. All right, so let's go ahead and create those. The database, we're going to use it and create that table. I will clear this, hit run, and it ran fine. So we'll clear that again. Now on the employee table, right, I'm going to have this common column between these two tables, and that column's called department ID. So I have an employee ID that's a small int, auto increment. The employee name, we'll just do name, not first and last name or whatever right there, varchar 50. We're going to have their address, and we have to put in a column that we're going to reference back to this column. So we just type just as normal, department ID, and we're going to make it a tiny int and not null in this case. Okay. Just to be different, I established the primary key at the column level. So I typed a comma here, and I said primary key is employee ID. It doesn't matter. I could have put primary key up here, or you could do it down here. It really doesn't matter. But now, here's the good stuff. Here's the foreign key. Here's what we're doing. We type the words foreign key. We list the column in the employee table. All right, we're saying, hey, this column in this table references in this table that column. Okay, so one more time. This column in this table, the employee table, so foreign key, department ID, what does that column reference? It references department ID. So it references the other table and this column in that table. So a couple key things to note here. The name of this column does not have to match the name of this column. The system doesn't care, because you're saying, hey, whatever I call this thing, it references this thing. Okay, so the names don't have to match. But what does have to match is the data types. So because I said this column references this column, the data types had better match. I can't make this a char and say that this char column is referencing a tiny int. I'll get an error. All right, so that's important. You have to pay attention when you define this common column between the two tables, that they have the same data type. They don't have to be the same name. Very often they are, but the same data type is required. So that's it. Foreign key, the name of the column, references the other table, and what column is in there. So now I will go ahead and establish our employee table, or create it. It ran just fine. So now let's test. What does this foreign key do? Okay, so real quickly, let's insert into three departments: accounting, engineering, and human resource. We will select those departments and see that they're all there. Yep, department 1 is accounting, 2 is engineering, 3 is human resources, so that worked. Now we're going to insert an employee. All right, so we're going to give him whatever ID, it's auto increment. There's the name, the address, and the department ID. All right, so we're saying Lou belongs to department 1, which was accounting. So we'll go ahead and insert that. And if you look at my output table, green check, which says, yep, we inserted that employee. But now here's the interesting part. What happens if I try to insert an employee? There's their ID, the name, the address, but I choose a department ID that does not exist in the department table. Because we have that foreign key constraint, we should expect an error. So I'm trying to insert Sally into a department that doesn't exist. When I run that, here's your error. Cannot add or update a child row. A foreign key constraint fails. So by the way, the terms parent and child. Basically, in this case, this is the parent table and this is the child table. So the department ID can be over here several times because the department can have several employees. So at the child table, this is considered the parent table. So in that error message, you're saying, I cannot update a row in the child table, which was the employee, because of a foreign key constraint. So that's maintaining our referential integrity. Don't let me put somebody in a department that doesn't exist. And presumably it's just an accident that you mistyped. So you're trying to put somebody in 5 when you really meant to hit 3. So now let's demonstrate another concept, and that is, or a similar concept I should say. I'm going to select, I just wrote that line, select my employees. Remember, I only stuck in 1, and he belongs to department 1, right? So Lou belongs to the accounting department. What happens when I try to delete that department from the department table, right? So for whatever reason, somebody tries to delete the department. So watch what happens here. I'm going to clear my output. I'm going to run that line. I'm deleting the department where the ID equals 1. I get an error. Cannot delete or update a parent row because of a foreign key constraint, right? Because what would you want to happen? I'm deleting department 1, and yet I have employees over in the employee table who have that 1 sitting in that department ID column. Okay, so it'd be the same thing if in the orders table I've got customer 1010. What if I try to delete that customer? Well, what do I want to happen over here? So what the foreign key constraint does, at least right now, we're going to talk about that, is it prevents you. It says, nope, you can't delete that department because it's being used in the employee table. Now, most of the time, that's the action you want to happen. It kind of makes sense. Don't let me delete a department that's being used. But there is language we can add to that foreign key constraint that makes will give us a different result. And so here's the language right here. Let's run back up to our employee table and add this language. I'm going to copy this. Okay, back at the top of the script, I'm going to start fresh. I'm going to drop my database, recreate it, use it, and recreate the department table. So no big deal there. Hopefully everything runs. I got green check marks. Now on my employee table, I'm going to recreate it, but I haven't run it yet. Here's my foreign key constraint. So that field, that column, department ID references this table, this column. This typing has to be exact. Whatever you called this table, you'd better spell it the exact same way down here. And whatever you called this column up here, you'd better spell it the exact same way down here. Okay, I get a lot of students having issues where they just aren't paying attention to their typing. And so they can never create this table because they reference something that doesn't exist because of a typo. Anyway, so now, notice there's no comma here. I'm going to add on delete, meaning when something gets deleted from the parent table, what do I want to happen to the child table? And these are my choices. You don't do all of these. You do one or the other. By default, if you don't put on delete, it's going to do restrict or no action. Those are the same thing. And that's what I demonstrated already. I tried to delete that department, that restricted it, or it basically did a no action. It says, nope, you can't do that. So that's the default selection if you don't type anything. It's going to either restrict or do a no action. Okay? So your other choices are to cascade or set to null. So here's what Cascade will do. If I delete Department 1 and there's employees in the employee table that belong to Department 1, Cascade will delete those employees. Ooh, so I don't know how often you want that to happen, but that's what Cascade would do. You delete a department, the employee table, it will run through and find every employee that belonged to that department and delete them also. That's what Cascade does. The other choice is to set null. So in other words, I delete Department 1, it's going to run to the employee table, and every time there's a Department 1 in the employee table, it will just set that field to null as long as that department field is nullable. So for instance, right now, I got this as not null. So if I say set it to null and then I have a not null here, well, I have a conflict. So basically, I would have to get rid of that if that's what I want to have. So if I delete Department 1, it's going to run into the employee table, and every place there's a 1, it'll just eliminate it and make it a null, put in a null marker. All right, and then of course no action was the same as restrict. So just for fun, let's demonstrate the cascade, and I know this is all fun. And so there's on delete, cascade, and by the way, there's on update. So what happens if I update the department number 1 and I want to make it for whatever department 10, which is bad form to be changing your primary keys, but for whatever reason you're changing the primary key from 1 to 10. So should I stop somebody from doing that? Or should I run through and change the primary key in all the other, in the employee table, so it's also 10, so I could cascade that change? Or should I restrict as the same as no action? Or could you run through and set null? So you have the same choices, on delete and on update. So we'll go ahead and do the cascade option here also. Get rid of the rest of my comments. And so now this is one statement. I think I have to get rid of that comma. I'm trying to figure out why I have that red squiggly on the on, and I just found it is I have a closing parentheses for my original create table statement, and now I need to put that closing parenthesis down here. So I have foreign key, that column, references that table, that column, and then I got two on an on delete cascade and an on update cascade. So now we can create that table. I'll run through here, hit update or create. I have my new table. Let's hurry up and populate our department table with our 3 departments. I'll stick Lou in the accounting department with a 1. And now down here, real quick, I'm going to select from employee. Oh, what happened? That's an unusual error. Empty string, give it as an argument for the exclamation point character. I don't know what that error means, and a little bit of investigation. I figured out my company wasn't selected, it wasn't being used, and so then when I selected my company and ran it, now I'm getting my one person, right? So Lou in Department 1. Okay, so now the whole point was, if I were to delete Department 1, remember we said Cascade this time. So guess what's going to happen? I'm going to run that, and I get one row affected. Okay, so Department 1 will no longer be in the department table. So when I select that, I only have Department 2 and 3. And guess what happens when I select from my employee table? Nobody will be in there anymore. So it's an empty table because I cascaded that delete onto the other tables. And the same thing would happen with an update. If I were to update a department, let's go ahead and add Sally to Department 2. We'll go ahead and put her in there, and we're going to update. We'll set Department ID 5 where it used to be at 2. So I will go ahead and do that, and that will cascade. So when I run that, when I go to select star from employee, she should now belong to Department 5 because it cascaded that update. So remember, if you don't put any on delete or on update commands or line in your foreign key statement, it will automatically default to restrict, which is probably the most common thing you want to happen, is don't let me delete departments or customers or whatever when that information is being used in another table. The next thing I'll demonstrate is the fact that you can have more than one foreign key in a table. So far we haven't talked about this zip code table, but what it has is just a zip code like 97702. The fact that that's Bend, Oregon. All right, well, I'm going to use that zip code as a foreign key over here. It's the primary key here, foreign key here. That way I can establish, I can just look at the zip code and know what city state they're from, rather than listing the city state in this table. So now the employee has, see these two red triangles? That's two foreign keys. So here's what that would look like. Running back to our script. Here it is again. I think I'll just start fresh. I'm going to drop my company, recreate it, use it, create the department. Okay, so we'll run all that. And now I want a new table called zip code, which will have nothing but the zip code, the city, and the state in it. And in my employee table, I need to add another column, right? I have to have a column that this is the common column, and I'll call it zip code. And remember, the data types have to match. So down here I said it was a char 5. Well, I better make it a char 5 up here or I'm going to get an error. Right there. So there is my common column. It's zip code up here, it's zip code down here. Here's my primary key statement. Here's the foreign key statement for the department, comma, and I didn't put in any on deleting or on cascading optional commands afterwards. And here is the foreign key statement for the zip code. So what I'm saying is this column, and notice I have a spelling error. I've got an underscore code here and I don't up here, so I better line that up. So this column in this table references this table, that column, and again the spelling has to be right between these two statements. But here's the interesting thing. Watch what happens when I try to create this table. Not to mention, I think I have a typo, right? Here's my opening paren. I got to put in my closing paren down here. Okay, so when I try to run this table, I'm going to get an error. Let me clear my thing. And okay, create table. It cannot add the foreign key constraint. And here's why. I'm saying that this column references that table. Well, guess what? That table hasn't been created yet, so it has no idea what the heck you're talking about. So now that we're messing with foreign key constraints, you have to start paying attention to the order that you write your script. You have to create your parent tables first before I can start referencing them in the child table. So in other words, I have to control X this and make sure that that table gets created before I can start referencing. So of course this reference worked because I have already created the department. This one died because I haven't created zip code yet. So if you're writing a script that you want to be able to run in one big fell swoop, you got to make sure you put things in a proper order. So now let me create the zip code first. This table, when I create it, should work because it now understands that there is a zip code table. Oh, we still have a problem. So I'm getting an error on creating this zip code foreign key constraint. So the first things I look for is make sure my spelling is the same between these two names and my spelling is the same between the table and that name. The next thing I look for is that the data type between this column and that column is the same, which they all are. So then what I discovered is, oops, I forgot to make zip code a primary key. All right, so a primary key in one table becomes a foreign key in another table. Because I didn't make this a primary key, I can't do a foreign key reference on something. If zip code being primary key makes it unique, right? Well, if it's not going to be unique, how am I going to reference that? So zip code has to be unique up there. So I'm real quickly going to drop that zip code table and rerun it. Add in the primary key on that column. Now when I create the table, I should have two foreign keys, one for the department ID to the department table, one for the zip code. So there, now it's running. The point being of that whole exercise, it was you can have multiple foreign keys in a table and you just separate each constraint by a comma. So for instance, I may have a unique constraint that I could add on the address or employee name or whatever. I would just put another comma and add that constraint next. So the last thing I'll talk about in this video is once you start messing with foreign keys, obviously the order that you create the tables is important. Parent tables have to get created first before the children table can reference them. The other one is now the order you drop tables becomes important. So if I try to drop zip code, whether through command or if I run over here and try to right click and drop it, it's not going to let me because it recognizes, hey, this table could be used in the employee table, so I'm not going to let you drop it. That employee table refers to me. So I'm not going to let you drop me because I'm being referenced up here. So basically what it means is I have to drop the employee table first, then it'll let me drop the zip code because now I'm not being referenced anywhere. There's one way around that, and there's another one of these set commands. And you can basically set foreign key checks equal to 0 and say, hey, ignore all the foreign keys for a minute and just let me do whatever the heck I want. So if I run that, now it's going to go ahead and let me drop that zip code table. And it doesn't care that the employee table references that. But of course now we're kind of creating a mess because I'm referencing a table that no longer exists. So just be aware, in the same way that you have to pay attention to the order you create things, you have to pay attention to the order that you drop things. So that should do it for the foreign key constraint. Just pay attention. The name of that column right here has to, you have to match the name, but it doesn't have to match the name of the other column, but it does have to match the data type. So if this is a tiny int, well then it better be a tiny int up in the original table. And then of course watch your typing. Whatever you called that table, you have to spell it the exact same way down here. Whatever you call that column, you have to spell it the exact same way down here. On delete or on update, again those words are cascade, set null, restrict to no action. If you just leave them completely off, which is a possibility, then it just is going to do the restrict or no action. So I can't delete a parent row record if it's being used as in a child table.